So in the last section we covered 30, 60, 90 triangles and the sides. So opposite of 30 degrees is 1, opposite 60 degrees is the square root of 3, opposite 90 is 2, and we had a 45, 45, 90 degree. So this was a 1, 1, square root of 2. Now if we move, instead of just being in the first quadrant, as we move around, we could have a 30, 60, 90, 1, square root of 3, 2 triangle. But now, because we went back, that's actually going to be a negative, so this is where we have to be careful of our signs. Since we went up, that's positive. But what is theta? Theta is really 150 degrees. So if we say find sine of 150 degrees, cosine of 150 degrees, and tangent of 150 degrees, and we're looking for the exact values. Remember, any exact value is going to be a 30, 60, 90 triangle, a 45, 45, 90 triangle, or our unit circle, which was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. But these triangles can move into different quadrants. So if we have sine of 150, this reference angle, that's what we're going to call this reference angle is going to be 30 degrees. So it's going to be our 30, 60, 90 degree triangle in the second quadrant. So sine is going to be opposite 1/2. Cosine of 150 degrees is going to be adjacent over the hypotenuse, negative square root of 3 over 2. And tangent is going to be opposite adjacent, so it's going to be 1 over negative square root of 3, which is negative square root of 3 over 3. And then we could do our reciprocals as well. But this idea of these 30, 60, 90, 45, 45, 90 triangles are going to be of any angle now, not just angles in the first quadrant as we move around. So as we do that, we need this idea of reference angles. So if we're theta's above 90 degrees and between 90 degrees and 180, it's going to be in the second quadrant. So here's our angle, but this between our terminal side and the x-axis is going to be our reference angle. If we're in the third quadrant, between the x-axis and the terminal side, here's going to be our reference angle. We're going to refer to this as theta prime. And in the fourth quadrant, from the terminal side to the x-axis, here's our reference angle here. So to find the reference angles now, in the first quadrant, theta and the reference angle, the angle and the reference angle are going to be the same. So these are going to be the same. In the second quadrant, well, it's going to be going all the way around to the x-axis. It's 180 degrees. Then we're going to come back and subtract off theta to find this angle right here, our reference angle. In the third quadrant, as we come down, now here's 180. How much further did we go? So it's going to be our angle, which is between 180 and 270. Our angle minus 180 will give us that angle there. And in the fourth quadrant, as we come around, it's going to be, here's 360 degrees minus our theta as we come around. Now again, we're going to be getting to those triangles if it's asking for exact. So remember that we're going to always go down to the x-axis, or in the third quadrant, up if you can see it, in the fourth quadrant, up. Okay, but as we go over, think of it x, y, always back to your origin. But it's going to be, here's our x, here's our y, and here's our hypotenuse. But this is going to be our triangle that we're going to be using with our reference angle, our triangle, right triangle, with our reference angle. So that way, if we're finding exact values, remember that's the key. If you're looking for exact values, it'll be one of those 30, 60, 90, 45, 45, 90, or unit circles. So again, if we're doing 150 degrees, well, we know that angle is in the second quadrant. Here's 150 degrees. So now my reference, so here's my triangle, my reference angle is going to be 30 degrees. So if we're looking for that theta prime, it's going to be 180 degrees minus 150 degrees, which is your 30 degrees. So if this triangle is 30 degrees, or if this angle is 30 degrees, it's a right triangle. We know that these are complementary angles, so this is going to be 60. So there's our 30, 60, 90 degree triangle. Opposite 30 is 1, opposite 60 square root of 3, and the hypotenuse is going to be 2. Now we have to be careful because we're in the second quadrant. So sine, if we remember, sine of 150 degrees, cosine of 150 degrees, and tangent of 150 degrees, cosecant 150 degrees, secant 150 degrees, and cotangent 150 degrees. So when we're in the second quadrant, you have to remember that there's going to be 4 negative and 2 positive. So cosine, secant, tangent, and cotangent are negative in that second quadrant. But how do we match this up? Because we're going back, we know that this square root of 3 has to be negative. So now we can use this to find our 6 trig functions. Sine of 150 degrees is going to be 1/2, opposite over hypotenuse. Cosine is going to be negative square root of 3 over 2, adjacent over hypotenuse. Tangent is going to be 1 over negative square root of 3, opposite over adjacent. So this is equal to negative square root of 3 over 3. Now the reciprocals, so 2, negative 2 over the square root of 3, and I'm going to use this one, negative square root of 3. Now these are exact values. We don't want decimals for this. But as you go through, you could check these on your calculator. So if we go sine of 150 and 1 divided by 2, you'll notice 0.5, 0.5, 1/2. If we say cosine of 150, we get negative 0.866, and if we go negative square root of 3 divided by 2, make sure you close your parentheses or get out of the square root, you're going to see that those values are the same. And if we do tangent of 150 degrees and negative square root of 3 divided by 3, you're going to notice those values are the same. So even though exact values, as we're find the exact, if you can see it there, we're going to include the radicals in our answers, but you can still check the decimals of these on your calculator if you want. So now 225 degrees. So 225 degrees is going to be in the third quadrant. So we're going to come back to the x-axis. So how we find theta prime, it's going to be, in this case, theta 225 minus 180 for that x-axis, and you're going to get 45 degrees. So this reference angle is 45 degrees, which means it's at 45, 45, 90. The sides are 1, 1, square root of 2, but double check your signs because we're going back and down. This is actually a -1 and a -1. So sine of 225 degrees is opposite -1 over the square root of 2, which is negative square root of 2 over 2. Cosine of 225 225 degrees is adjacent, negative 1 over hypotenuse, square root of 2, which is negative square root of 2 over 2. The tangent of 225 degrees is opposite, negative 1 over adjacent, negative 1, which is 1. Now for the reciprocals, cosecant 225 degrees, secant 225 degrees, and cotan 225 degrees. This is going to be negative square root of 2. Secant 225 degrees is negative square root of 2, and cotangent is 1. But again, once you leave that first quadrant, notice we have 1, 2, 3, 4 negative and 2 positive. Find the exact values of 300 degrees. So that's in the fourth quadrant. So if this is 300 degrees, then theta prime is going to equal 360 degrees minus 300, which equals 60 degrees. So this reference angle is 60 degrees, which makes it a 60-30, or 30-60-90. Opposite 30 is 1, opposite 60 square root of 3, and the hypotenuse is 2. But the next thing is that sign. As we go to the right, it's positive. As we go down, it's negative. So sine 300 degrees, opposite over hypotenuse, negative square root of 3 over 2. Cosine 300 degrees, adjacent over hypotenuse, 1/2. Tangent 300 degrees is equal to opposite over adjacent, negative square root of 3 over 1. Cosecant 300 degrees is equal to negative 2 over the square root of 3, which rationalizes to negative 2 square roots of 3 over 3. The secant of 300 degrees is equal to 2, and the cotangent 300 degrees is equal to 1 over negative square root of 3, or negative square roots of 3 over 3. And if we take the time to check some of these, I'm not going to check them all, but you should, as we go through. If we say the sine of 300 degrees equals that negative 0.866, and if we go negative square root of 3 closed divided by 2, you're going to notice we're getting the same value. If we do cosine of 300 degrees, there's 1/2 0.5, 1/2 0.5. Okay, and you can check tangent and the reciprocals as you go through as well. Now, how about if theta equals 390 degrees? Well, if it's larger than 360 or smaller than negative 360, it's including a rotation as we go around. So 390 degrees is coming around. There's 360. Now how much further? We're going to go another 30 degrees. So this is a 30, 60, 90. Opposite 30 is 1. The opposite 60 is the square root of 3. And the hypotenuse for this one is 2. And again, you should be able to check that in the Pythagorean. But as we go through, this is a 30, 60, 90. So the sine of 390, so we're still going back to this angle, cosine of 390, tangent of 390. Sine of 390 is 1/2, opposite over hypotenuse. Cosine of 390, adjacent over hypotenuse. And tangent of 390 is going to be opposite over adjacent, which rationalizes square root of 3 over 1. So now we have cosecant 390, secant 390, and cotan 390. Cosecant's 2. Secant's 2 over the square root of 3, which is 2 square roots of 3 over 3. And cotangent is the square root, or the square root of 3. But this is, going back to tangent for a moment, this is the square root of 3 over 3 as you rationalize it. So if we go negative 495, so we go negative 495, if we add 360 to that, we get negative 135. So what that's really doing is, as we come around, there's negative 360, and now we need to go another negative 135. So if that's negative 135, we could add our 180 into that, and you're going to see that reference angle is 45 degrees. So it's a 45, 45, 90. So this is 1, 1, square root of 2, back and down, negative 1, negative 1. So the sine of negative 495 degrees. Now, if you recall, we had one like that, 225 degrees. We're going to get the same answers because 225 degrees and negative 495 degrees are coterminal angles. So we're actually going to get the same values here. Cosine negative 495 degrees and tangent negative 495 degrees. Sine opposite over hypotenuse, negative 1 over the square root of 2, or negative square root of 2 over 2. Cosine adjacent over hypotenuse, negative 1 over the square root of 2, which is negative root 2 over 2. And tangent's negative 1 over 1, which is 1. So notice tangent's positive in the third quadrant. So negative, negative, positive. Cosecant negative 495 degrees, secant negative 495 degrees, cotangent negative 495 degrees. So this is going to be negative root 2, negative root 2, and 1. 4 negative, 2 positive in the third quadrant, tangent's positive and cotangent's positive. So we can add more rotations. We have 1500 degrees. So we can start out to see how many rotations that is. 1500 minus, we can start with 4 if you want. 4 times 360. And that was actually pretty close. We get 60. So that one's going to go around 4 times. So it's going... There's 360 positive. 1, 2, 3, 4. Now go another 60. So this reference angle here is going to be 60 degrees, and which is 30, 90. So again, that was our reference angle of 60. If we didn't guess that, if we said 1500 minus 3 rotations times 360, notice how that's bigger than 360, so we just subtract another 360 then. So you want to go until you get that positive reference angle, or you can figure it out, but that reference angle is going to be between 0 and 90. Opposite 60, square root of 3, opposite 30, 1, 2, and again, right up, positive, positive. So the sine of 1500 degrees, opposite over hypotenuse, square root of 3 over 2. Cosine of 1500 degrees is equal to adjacent over hypotenuse, 1/2. And the tangent of 1500 degrees is equal to opposite over adjacent, square root of 3 over 1. the cosecant 1500 degrees is 2 over the square root of 3, which is 2 square roots of 3 over 3. The secant of 1500 degrees is equal to 2, and the cotangent 1500 degrees is equal to 1 over the square root of 3, which is the square root of 3 over 3. So this is if we're finding all 6 trig functions. But again, notice whenever it said find the exact, find the exact, find the exact, it's going to be either a 30, 60, 90, a 45, 45, 90, or a unit circle to find those exact values. Now, instead of finding all 6, if they're just looking for 1 or 2, again, exact values, I'm going to have to show the work. I can check it on the calculator, but this is going to be 480. So there's 360. So how much further do I have to go? I have to go another 120. Well, then I know, if you can see, so if this is 120, then this is going to be 60 degrees to get back to that 180. 30. So this is the square root of 3, 1, 2. So this is back, it's to the left, so that's negative, up is positive. So this is going to equal opposite over hypotenuse, square root of 3 over 2. If we're looking at the tangent, so now I'm going this way, around and around and around. So if I start out negative 1,950 plus 360, how many rotations are we thinking? We'll say times, before it was 4. 4 is not enough, if you can see, so I'm going to add another. So I get negative 150. So as we go around, I'm going to start negative, going to go through 5 rotations, and then I'm going to come down negative 150. So that's going to be in the third quadrant. This is negative 150, then regardless of the direction, negative, it's still going to be 150. I need another 30. So this is a 30, 60, 90, 1, square root of 3, 2, back down, negative, negative. So the tangent is going to be negative 1, opposite, over negative square root of 3, adjacent, or positive, negative divided by negative. This is going to be the square root of 3 over 3. And don't be afraid to check it on your calculator. If we're looking for the tangent of negative 1,950 degrees, remember we're in degree mode on your calculator, and if we go the square root of 3, close your parentheses, divided by 3, what do you notice about those values? They are the same, so you should feel pretty good about that. Then we could check it with the other one as well. Sine 480, 0.866, the square root of 3 divided by 2, 0.866. These are rounded values, the decimals, because when you stop you're going to be rounding, versus with the radicals, this is the exact values. So if we want to determine now if this statement is true or false, notice we have a 30, 60, 90. So I'm going to use my 30, 60, 90. Opposite 30 is 1, square root of 3, 2. And for 90, remember, I'm going to need my unit circle. For 90, I'm going to use 0, 1. So now the sine of 30 is 1 opposite over hypotenuse. So this is 1/2 plus the sine of 60. So here's 60 now. opposite over hypotenuse is going to be the square root of 3 over 2. And does that equal, what's the sine of 90? Well, that's going to equal 1. Does 1/2 plus the square root of 3 over 2 equal 1? The answer is no. So this is a false statement. That's not true. How about cosine 60 degrees equals 2 cosine squared 30 minus 1? So cosine 60, well, I already have my triangle here. Cosine 60, though, is going to be adjacent over hypotenuse. That's 1/2 equal 2 times, I need the cosine of 30 degrees. Cosine of 30 degrees is going to be adjacent over hypotenuse, square root of 3 over 2 minus 1. So does 1/2 equal 2 times, this is going to be 3 over 4 minus 1. Does 1/2 equal 6/4 minus 1? Does 1/2 equal 3/2 minus 1? Does 1/2 equal 1/2? And the answer is yes. So this is a true statement. Now if I want a 45, sine squared 45 plus cosine squared 45, I'm going to need my 45, 45, 90. 1 square root of 2. So this is going to be the sine of 45, which is 1 over the square root of 2 squared plus hypotenuse. 1 over the square root of 2 squared, and does that equal 1? This is going to be 1/2 plus 1/2 equal 1. 1 equal 1? Yes. So this is true as well. But again, could check these on your calculator. So that's the work. So you're going to have to show the work as you're going through this to determine true or false. But if we use our calculator, sine 30, close your parentheses, plus sine 6, your parentheses, and go sine 90, you're going to see that those are not the same. If we go cosine 60 and 2 cosine, now we're going to have to put those parentheses in. Cosine 30, close the 30 degrees, close the cosine, now square it, minus 1. You're going to see those values are the same. And same with sine 45 squared plus cosine 45 squared. And notice we get 1 and we get 1. So as we go through, we're going to do this by hand using our 30, 60, 90, 45, 45, 90 triangles or the unit circles, and these will be nice values, or I should say nice angles as you're finding those. So now we're going to do something different. We want to find all values for theta between 0 and 360 degrees. So we're referring to one rotation. So what we're really looking for now is we're looking for the angle where sine theta equals the square root of 3 over 2. Well, how do we do this is sine theta is positive in what quadrants? So there's really two answers for this between 0 and 360. Because it's positive in the first and it's positive in the second. So now since sine is opposite over hypotenuse, this is the square root of 3 over 2, square root of 3 over 2, and you should recognize that this is one of our special triangles where this is 1, 1, because we're going back, this is really negative 1. So opposite the square root of 3 is 60 degrees. This is our 30, 60, 90 degree triangle. Opposite is going to be 60 degrees, 30 degrees, 90. So if we're looking for theta, theta is going to equal this angle in the first quadrant, which is 60 degrees, and theta is going to equal this angle in the second quadrant that has a reference angle of 60. So how do we find that? It's 180 minus 60 will give us that angle, which is going to be 120 degrees. So there's two answers. And we can check these. If you go and check them, we're going to have the sine. So the sine of 60 degrees and the square root of 3 divided by 2 and the sine of 120 degrees. What do you notice about all those? So the sine of 60, square root of 3 over 2, and sine of 120, they're all the same value. So when you're solving these, you can check them on your calculator. Where is cosine theta equal to negative? Well, it's going to be in the second and third quadrant. So as we go through now, cosine is going to be adjacent, negative square root of 2 over hypotenuse to 2. Now this one may not look nice, but if we start to solve this, negative square root of 2 squared plus y squared equals r squared. So this is 2 plus y squared equals 4. This is y squared equals 2. Y equals plus or minus the square root of 2. So this is going to be, since we're going up, positive square root of 2, negative square root of 2. And since these sides are the same, these angles have to be the same. So this is our 45 degrees, 45 degrees, 45 degree, 45 degree triangle. So even though it didn't look like that, if you remember when we were rationalizing all of these with a reference angle of 45, it was negative square root of 2 over 2. So now to find theta, we need this angle that has a reference angle of 45 degrees. So it's 180 minus 45, which is going to be 135. And then we need this one here to get to here. So it's 180 plus 45, which is going to be 225 degrees. So again, how do we find that? It's theta equals 180 degrees minus 45 for the quadrant 2, and theta equals 180 degrees plus 45 for quadrant 3. So 135 degrees, 225 degrees. And you can use your calculator to check. So now tan theta equals 1. Again, for one rotation, 0 degrees to 360 degrees, tangent's positive in the first quadrant and the third quadrant. Tangent's opposite, 1. You can think of this as 1 over 1. Over adjacent, opposite, adjacent. So there's our square root of 2. But because we're going back and down, remember that's negative, negative. But what are my angles here? 45 degrees and 45 degrees. So my first one, theta equals 45 degrees, and my next one, theta equals 180 plus 45 degrees. So it's 180 plus in the third quadrant. So we get 225 degrees. And again, don't be afraid to check these. If we go tangent 45, we get 1. Tangent 225, we get 1. And we were supposed to get 1. Just a couple more examples. So here's a secant theta equals negative 2. Remember, that's the same thing as cosine theta equals negative 1/2. That reciprocal identity. Whereas cosine negative in the second and third, it's adjacent, negative 1, 2, 2. This is going to be our square root of 3, negative square root of 3. And if you can't remember, when you have two sides, you could always use the Pythagorean theorem to find the other side. So opposite square root of 3 is 60 degrees. 60 degrees. So this is theta equals, so that's going to be 180 degrees minus 60, which is 120 degrees, and theta equals 180 degrees plus 60 for quadrant 3, which is 240 degrees. So 120 degrees and 240 degrees. So cosine, so we want to get negative 1/2, so if we go cosine 120 degrees, there's that negative 0.5, and cosine 240 degrees is negative 0.5. Cotangent theta equals negative square root of 3. That's saying the same thing as tan theta equals negative 1 over the square root of 3 for the reciprocal. Whereas tangent negative in the second and fourth, so it's opposite 1 over adjacent square root of 3, opposite 1 over adjacent square root of 3, but one of these has to be negative. Now remember, this is the same thing as 1 over negative square root of 3. So here, because we went back, there's our negative, and here, because we went down, here's our negative. But 1 square root of 3, that's our 2. So that's opposite 1 is, for 1 square root of 3, 2. It's going to be our 30 degree, 60 degree triangle. And this is our 30 degree, 60 degree triangle. So here it's going to be theta equals 180 degrees minus 30 in the second quadrant, so 150 degrees. And in the fourth quadrant, theta equals 360 degrees minus 30, which is 330 degrees. So theta equals 150 degrees and 330 degrees. So that's solving. So remember, if you're solving between 0 and 360 degrees, it's going to be negative in two quadrants. So you're going to have two answers. So, and here was how we found our angles. You know, notice we're always using the x-axis, so it's going to be 180 minus, 180 plus, 360 minus, and in the first quadrant, it's going to be the same, the reference angle and the angle. So I hope this helps with section 6.2. If you have questions, please email me.